Holy crap, you clicked on this video because something told you that title was real. And it is. There is one simple thing you can eat with bread, pasta, rice, or any carb you love, just 10 grams. And it quietly dismantles one of the most damaging processes happening inside your body every single time you eat a carb. Not slowing it down a little, not making it marginally better, actually restructuring how your body processes that meal. Most people have no idea this is even possible, because most of what you have been told about carbs is either incomplete, outdated, or designed to make you feel like the only option is to eat less. But what if the problem was never the bread? What if the problem was the order, the combination, and the biological context in which you were eating it? That is what this video is about, and by the end of it, you will never look at a meal the same way again. Let us start with what is actually happening in your body when you eat carbohydrates, because most people have a vague idea, but not the full picture. And the full picture is where everything changes. When you eat bread, white rice, pasta, a potato, or any starchy food, your digestive system breaks those carbohydrates down into glucose. That glucose enters your bloodstream, and your blood sugar rises. This is not inherently dangerous. This is normal. Your body was designed to handle glucose. The problem is the speed. When you eat refined carbohydrates, especially on an empty stomach, without fat, fiber, protein, or anything else to slow absorption, that glucose floods your bloodstream rapidly. Your pancreas detects the spike and releases insulin in a large, urgent wave to shuttle that glucose out of the blood and into your cells. The more dramatic the spike, the more dramatic the insulin response. And here is where most of the damage happens. Insulin is not just a sugar shuttle. Insulin is one of the most powerful hormonal signals in your body. When insulin is high, fat burning stops completely. When insulin spikes repeatedly throughout the day, your cells begin to resist its signal over time. A process called insulin resistance. When insulin crashes after a spike, it triggers hunger, cravings, fatigue, and a relentless desire to eat again within an hour or two. This is the cycle that is making people sick, tired, and unable to lose weight. Not because they lack willpower, but because they do not understand the physiological trap they are walking into 3 times a day. Now, here is what the research has been quietly revealing over the last 2 decades, and what most mainstream nutrition advice has been shockingly slow to incorporate. The glycemic response to a meal is not fixed. It is not determined solely by the carbohydrate content of the food. It is powerfully shaped by what you eat, alongside those carbs, what you ate before them, and in what order the foods arrive in your stomach and intestinal lining. This is called the food matrix effect, and it is one of the most underexplored concepts in public nutrition education. So, what is the 10 grams that the title promised you? It is viscous, soluble fiber. And before you check out, because you think you already know about fiber, stay with me. Because what most people understand about fiber is the beginner version. The deeper mechanism is genuinely shocking. There are 2 broad categories of dietary fiber. Insoluble fiber, which adds bulk and helps with bowel movements, and soluble fiber, which dissolves in water and forms a gel-like substance in your digestive tract. Most of the fiber conversation in popular health media focuses on the first type. But the second type, specifically a subgroup called viscous soluble fiber, is where the metabolic magic lives. When viscous soluble fiber enters your stomach and intestines, it absorbs water and swells into a thick, gel-like matrix. This gel coats the inner lining of your small intestine and physically slows the rate at which digestive enzymes can reach carbohydrate molecules. It creates what researchers sometimes call an unstirred water layer, a barrier that glucose must diffuse through before it can reach the intestinal wall and enter the bloodstream. The result is a dramatic reduction in the speed of glucose absorption. Not the amount in most cases, but the speed. And as any endocrinologist will tell you, it is the speed of glucose entry that drives the insulin spike more than almost anything else. The clinical data on this is remarkably consistent. Studies published in journals like Diabetes Care, the American Journal of Clinical Nutrition, and Nutrition and Metabolism have shown that adding just 8 to 12 grams of viscous soluble fiber to a carbohydrate-containing meal can reduce the postprandial glucose peak by anywhere from 15 to 35%, depending on the individual, the source of fiber, and the carb load. Some studies show even more significant reductions, particularly with the most potent viscous fibers like beta-glucan, psyllium husk, and glucomannan. Now, let us talk specifically about where these 10 grams come from, because there is a meaningful difference between fiber sources, and eating the wrong type will give you almost none of the metabolic benefits we are discussing. Beta-glucan is arguably the most well-studied viscous soluble fiber for glucose and insulin management. It is found primarily in oats and barley. A bowl of steel-cut oats contains roughly 3 to 4 grams of beta-glucan. Eating oats alongside other carbohydrates significantly blunts the spike from the entire meal. But the viscosity of beta-glucan is sensitive to processing. Instant oats, which have been pre-gelatinized to cook faster, have significantly lower viscosity than rolled or steel-cut oats and provide a meaningfully weaker metabolic effect. This is one of the most common mistakes people make when trying to eat healthy. The processing of the fiber matters as much as the presence of it. Psyllium husk is another highly viscous fiber, and it is particularly useful precisely because it is nearly flavorless, easy to add to any meal, and one of the most concentrated sources of soluble fiber available. 1 tablespoon of whole psyllium husk contains approximately 5 grams of soluble fiber. 2 tablespoons gets you to 10 grams. When dissolved in water and consumed at the start of a meal, or mixed directly into a starch-heavy dish, psyllium husk has been shown in multiple controlled studies to significantly reduce both peak blood glucose and insulin area under the curve, a measure of the total insulin burden across the 2 to 3 hours following a meal. Glucomannan, derived from the konjac root, is the most viscous dietary fiber known. It absorbs up to 50 times its weight in water. Studies suggest it is effective at doses as low as 3 to 4 grams taken before a meal with a large glass of water. It forms a gel so thick in the stomach that it physically delays gastric emptying, meaning the entire meal moves more slowly through your digestive system. Some researchers have proposed that glucomannan may be one of the most powerful non-pharmacological tools for managing postprandial blood glucose in people with prediabetes and type 2 diabetes. It is not widely discussed in mainstream nutrition circles, and that gap is hard to explain given the strength of the evidence. There is also a dietary pattern that many cultures practiced long before any of this research existed, and which we are only now understanding through a mechanistic lens. In traditional Japanese cuisine, meals often begin with a small bowl of miso soup containing seaweed, which is high in soluble fiber, before any rice or noodles are consumed. In many Mediterranean traditions, vegetables and legumes, both rich sources of viscous fiber, are eaten as appetizers before bread and pasta. These were not random cultural rituals. Whether consciously designed or not, they created a physiological pre-coating of the intestinal lining with fiber before the glucose load arrived. The fiber matrix was already in place when the carbs showed up. This sequencing matters enormously and is underemphasized in virtually every mainstream dietary guideline. Now, here is a layer of this story that most health content creators skip because it requires explaining a second mechanism and most people stop watching. But if you are still here, you deserve the complete picture. Viscous fiber does not only slow glucose absorption through mechanical means. It also interacts with your gut microbiome in ways that further modulate insulin sensitivity over time. When soluble fiber reaches the large intestine largely intact, it becomes a substrate for fermentation by specific bacterial species, primarily Bifidobacterium and Lactobacillus strains. The byproducts of this fermentation are short-chain fatty acids, specifically butyrate, propionate, and acetate. These molecules are not waste products. They are active metabolic signals. Butyrate is the primary fuel source for colonocytes, the cells lining your colon, and low butyrate production is associated with intestinal permeability and systemic inflammation. Propionate travels to the liver and suppresses de novo lipogenesis, which is the liver's process of converting excess carbohydrates into fat. Acetate enters the systemic circulation and has been shown to reduce appetite by acting on receptors in the hypothalamus. So when you eat viscous soluble fiber consistently, you are not just blunting today's glucose spike. You are running a background program that improves your insulin sensitivity, reduces fat storage signaling, feeds a healthier gut microbiome, and subtly suppresses appetite. This is why researchers studying high-fiber diets see benefits that accumulate over weeks and months in ways that a single meal glycemic measurement would never capture. But here is where the science gets more controversial, and where some of the most interesting debates in metabolic research are currently playing out. Not everyone responds to fiber the same way. A growing body of research, including landmark studies from the Weizmann Institute of Science, has shown that glycemic response to any given food can vary enormously between individuals, sometimes by a factor of 4 or 5, even when eating the exact same meal. Two people eating the same piece of bread with the same amount of psyllium husk can have completely different glucose curves. The reasons for this variation appear to include gut microbiome composition, genetics, prior metabolic history, sleep quality the night before, stress levels, and the timing of that meal relative to physical activity. This has led some researchers to argue that generalized glycemic index tables and even population-level fiber recommendations are blunt instruments at best, and that the future of dietary advice lies in personalization through continuous glucose monitoring combined with microbiome analysis. This is not science fiction. Consumer-grade, continuous glucose monitors are already available, and several companies are building personalized nutrition platforms around real-time glucose data. The direction the field is moving is away from universal rules and toward individual metabolic mapping. So where does this leave the average person who does not have access to a continuous glucose monitor or a microbiome sequencing kit? It leaves you with a set of principles that have the most robust evidence behind them and that work for the largest portion of the population, while acknowledging that your personal optimization may require more individual experimentation. Principle 1. Add viscous soluble fiber to every carbohydrate-heavy meal. 10 grams is a useful target. The specific sources that have the strongest evidence are psyllium husk, beta-glucan from oats or barley, and glucomannan. Mixing 1 to 2 tablespoons of psyllium husk into a glass of water and drinking it before or with a meal is one of the simplest and most evidence-backed interventions available for glucose management. Principle 2. Sequence your meals intentionally. Eat fiber and vegetables first, protein and fat second, and carbohydrates last. A series of studies by Dr. Louis Aron and colleagues at Weill Cornell Medicine demonstrated that simply changing the order in which foods are consumed at the same meal can reduce the postprandial glucose peak by up to 73% compared to eating carbs first. 73%. That is not a small effect. That is a meal composition strategy that rivals some pharmaceutical interventions in its acute impact on glucose, and it costs nothing. Principle 3. Do not eat refined carbohydrates in isolation, especially not first thing in the morning on an empty stomach. The modern breakfast of toast, cereal, orange juice, or a bagel consumed alone is one of the most glycemically aggressive ways to start a day. Adding eggs, nuts, avocado, or any source of fat and protein to that meal, or switching to a high beta-glucan option like steel-cut oats, fundamentally changes the metabolic story. Principle 4. Movement after meals matters more than most people realize. A 10 to 15-minute walk after eating activates GLUT, 4 transporters in your muscle cells, which allow glucose to be absorbed directly into muscle tissue without requiring insulin. This is a parallel glucose disposal pathway, and it is genuinely powerful. Studies show that post-meal walking reduces blood glucose area under the curve by 15 to 30%. When you combine fiber consumption with post-meal movement, the synergistic effect on insulin management is substantial. Now, let us address the question that is probably forming in the back of your mind. Is this just another way of saying eat less carbs? No. That is a fundamentally different message, and conflating the two misses the point entirely. The goal here is not to demonize carbohydrates. Glucose is the brain's preferred fuel. Carbohydrates have been part of human diets for hundreds of thousands of years. Many of the healthiest and longest-lived populations on Earth eat high carbohydrate diets. The problem is not glucose. The problem is the velocity and the context in which glucose enters your blood. A sweet potato eaten with its skin, alongside greens and olive oil, eaten at the end of a meal after vegetables and protein, consumed by someone who goes for a walk afterward, creates a completely different hormonal environment than a slice of white bread eaten alone on an empty stomach in the morning. The carbohydrate content might be similar. The metabolic consequence is not even close. This distinction matters because the public health conversation around carbs has become a binary war between low-carb advocates and those defending whole grains. When the more sophisticated and actionable question is not how many carbs, but what kind, in what context, combined with what, and in what sequence. The research on fiber, food ordering, post-meal activity, and the food matrix effect points toward a third path. One where you do not have to choose between enjoying food and managing your metabolic health. There is one more thing worth discussing before you go, and it is something that almost never comes up in nutrition content, but that every endocrinologist who works with metabolic patients understands deeply. Chronic insulin spiking is not just a weight management issue. Repeatedly elevated postprandial insulin over years and decades is implicated in a strikingly wide range of conditions beyond type 2 diabetes. Polycystic ovarian syndrome, which affects roughly 1 in 10 women of reproductive age, is now understood to be substantially driven by insulin dysregulation. Elevated insulin promotes androgen production in the ovaries and disrupts the hormonal cascade governing ovulation. Non-alcoholic fatty liver disease, now called metabolic-associated fatty liver disease by updated nomenclature, is driven in large part by the liver's response to repeated insulin surges combined with fructose overconsumption. Cognitive decline and Alzheimer's disease, which some researchers have controversially proposed, calling type 3 diabetes, are associated with insulin resistance in the brain. The brain's ability to utilize glucose as fuel depends on insulin signaling. And when insulin resistance develops systemically, it can extend to neural tissue. Accelerated skin aging, driven in part by a process called glycation, where glucose molecules bind to and stiffen collagen and elastin fibers, is directly linked to postprandial glucose peaks. The connection between diet and appearance is not primarily about calories. It is substantially about glucose management. This is why the 10 grams of viscous fiber conversation is not just a blood sugar tip. It is an entry point into a much larger framework for how the food you eat communicates with your hormones, your cells, your brain, and your long-term physical condition. It is a framework where small, consistent, mechanistically grounded changes compound over time into dramatically different health trajectories. You do not have to overhaul your diet. You do not have to give up bread or pasta or rice. You do not have to track macros or count calories. But you do have to understand what is actually happening inside your body when you eat, because once you understand the mechanism, the right choices become obvious. Not because someone told you to make them, because you can see with crystalline clarity exactly what is at stake. Start with 10 grams of psyllium husk before your next carb-heavy meal. Drink it with a full glass of water. Eat your vegetables first. Take a short walk afterward. Do that for 2 weeks and pay attention to your energy levels, your cravings, and how long you stay full. The feedback will be undeniable. That is the thing about working with your physiology instead of against it. The results are not subtle.